Okay, so in first looking at this problem, it seemed like it made sense to me to separate data from a flat data structure into a relational structure. This was my first time ever performing an ETL, and so I had a lot of fun kind of diving into ETLs and looking at pros and cons of different ways of doing it. So how I imagine this data looking is you've got restaurants as one entity. This was one of my models. The primary key here is the CAMIS number that each restaurant has. That's its unique identifier. And then you've got different inspections. And we know that inspections are related or associated with one restaurant. But restaurants can have multiple inspections, right? Each year, every 6 months, however long, they're going to get a different inspection. So restaurants have many different inspections, but inspections are always going to be associated just with one restaurant. And then we also have violations. So upon each inspection, you may have one violation that is found in multiple inspections. You might also have multiple violations found in the same inspection, right? You might be inspecting a restaurant and there are both flies in the kitchen and they're not wiping down counters. And also you might see flies in the kitchen of multiple restaurants. So inspections and violations have a has many or belongs to many relationship. And then your restaurants and inspections have a one-to-many relationship where each inspection is associated with one restaurant. Each restaurant has many inspections. And so that's how I kind of imagined restructuring the data. As far as my tech choices, so I imagined first taking this data, parsing the CSV file, and then restructuring it into this relational structure, and then piping that or loading that into a Postgres database using SQLize calls, because I'm very comfortable in SQLize and JavaScript, and Postgres is a great relational database that I thought would fit really well. And so our sort of biggest bottleneck there is actually piping like 500,000 entries all at once into my Postgres database. So that was going to be too much to sort of bulk create 500,000 entries all at once. That's where my big bottleneck hit. So I was looking for a way of doing this ETL job that allowed me to kind of manage that back pressure. And so what I found was this library, which I'll actually pull up here for a moment. So Node ETL. It's a library written for not just Postgres, but it's written for Node to be able to load data into a number of different databases. And the way that it allows you to manage that back pressure is because it takes the CSV file and it creates a read stream. And so all of the steps are in a stream. And so that manages at every step of the way the back pressure, which is really nice. And so we can look to the seed here. The first thing I did was create this read stream from the CSV file, parse it, and then map over that data and make a couple of changes just to syntax, taking these dates from just strings and making them into new dates of a slightly different structure. And then I'm returning, in this case, this is just loading in the restaurants data. So I'm returning just the data that I need for those restaurants. So what is the unique identifier, what's the name, the borough, etc., what's the cuisine. And then moving here, how I initially actually solved this was this database allows you to, or this library allows you to collect. So you can pipe ETL collect and collect a certain number of entries into packets. So I had collected 1,000 entries at a time, and then I was actually just kind of doing a bulk create here, just pseudocoding this in. So I would bulk create, I would map through those packets and then bulk create 1,000 entries at once. And so that allowed me to manage that back pressure that way. So instead of trying to bulk create 500,000 entries, we're taking these packets of 1,000, mapping over them, and one at a time, taking 1,000, right, one packet at a time, and 1,000 entries at a time, and bulk creating entries in my Postgres database there, which actually worked fine, but it wasn't using everything in the library. This step here is what I was not using at first, honestly, because I didn't fully understand how to employ it. And so what I actually did is I reached out to the guy who made the library. He's super nice. He was down to just Zoom call me, and we kind of chatted about his tech choices and how to employ this. He works at a big data analytics company for hedge funds, so they're doing lots of ETL jobs all the time, and it makes sense that they're working on trying to make those more efficient. So in talking to him and understanding the library a bit better, I was able to actually just continue to use the library, which didn't actually change the efficiency of my data input. What this is doing here is it's just piping into my Postgres database using SQL calls. So if we go back, this is what was pulled up here. This is the script for that. And so it's interesting because I could have used what I was doing before, which was collecting into packets, mapping over, and making those bulk creates myself, or writing those bulk creates myself. And that was kind of fine as well, sort of a wash as far as efficiency or time's sake. But I wanted to be able to use just everything from the library, just for sake of sort of syntactical clarity. I feel like when I'm mixing code from different places, it's just more likely to create weird behaviors that are unexpected. So I feel better about having this, but it works just fine either way. And what's fun about this also, which actually is a benefit, is that it allowed me to filter out repeats easily, because if you were looking at the script here, so for example, since I have a restaurants and a violations model, each just with one entry per restaurant or one entry per violation, I wanted to filter out repeats, because obviously we're seeing violations, the same violation over and over again in the flat data structure, the way that it is given on the NYC Health Department website. But here on conflict for your primary keys, they just do an update. So if I've already have violation 20C in my database, then, and it sees that again, it'll just update it, which is perfectly fine, because it should have the same information in my examples, because my violation model is only going to have the violation codes, their descriptions, and their critical flag. So that was actually a huge benefit of this library. Also, it made it easier to filter through my repeats. And so finally, we're moving down, and I just did the same process for violations and for inspections, where we're creating a read stream, we're parsing that CSV file, we're giving the particular columns that we need in our database model. And if you notice, inspections, for example, gets restaurant ID as well, because each inspection is associated with a restaurant. So you've got that as its foreign key. And then we do some error handling, and we're done seeding. So we can see that in my databases here. So if we're going into my orchard assessment database, it's all just one schema. Let's see if I can open this with these 4 different models. First, we've got restaurants, which has 27 pages of unique restaurants, each with their unique identifying number. A couple important things about them. We've got the cuisine, which becomes important because we want to find all the Thai restaurants. Then we've got our violations, which is only 1 page, if I can open things, with their unique identifying code here. And again, it's only 1 page because we're just taking, we're getting rid of all of the repeat data, and we're just taking 1 violation per entry here, so we can just relate them. And then inspections, we're given unique identifying numbers when they were loaded into Postgres, and this is where we're getting the grade, we're getting the inspection date, which becomes important because we want to choose the most recent inspection. Of course, a restaurant maybe had an A grade last year, but in their most recent inspection, they got a D, and we don't want to bring our friend to that restaurant. And then we have the restaurant IDs here, and you can see, as we would expect, we're seeing multiple of the same restaurant ID in different inspections, because each restaurant is going to have a number of different inspections. So the one piece here that is actually not working, that is the piece that I'm still working on and will continue to figure out, is my join table. So my join table is not populated. It does have the correct column names, so we want to have inspection IDs associated with violation codes. And what's great about this many-to-many relationship, this join table, is it allows us to have, ideally, a number of entries with the same inspection ID associated with different violation codes, and then flip side, the same violation code associated with different inspection IDs. So even though that's not populated right now, it actually doesn't get in the way of this particular project because we don't really need to know the individual violation that each restaurant was given. We just need to know what is the grade of that restaurant on its most recent inspection, and that allows us to still choose restaurants for our friend. So we can see that functioning here. Let's actually run this. And the way that I'm pulling the data here is I'm making an API call that's going to eager load both the restaurant information and its inspection data. And I'm only pulling restaurants where the cuisine is Thai and where there are inspections that are after January 1st and where the grade is either an A or a B. So all I'm going to get are restaurants that are potential candidates because they have a recent inspection with an A or a B grade, and then we can see those here. And so here's our list of top 10 restaurants, all of grade A, and we can see in our results what we're getting. So the one piece also that I don't think is the best solution right now, that with more time I would create a better solution for, is right now we're just pulling any inspection after January 1st of 2019 that has a grade of A or B. And to pull these results, I just took the first, knowing that they were all going to be a grade A or B, I just took the 0th index and that specific inspection, and that's what I'm populating this table with. But I know in an ideal world, we would like for this to always be pulling the most recent inspection. There's a chance that the second entry here is actually a more recent inspection than the 0th index. I would need to go in and continue to check that. So the better solution would be to find the most recent inspection. But again, for the sake of our challenge here, this works just fine because these are all inspections within the last 18 days with grades of A. And so that's working there. And I think that's all I have to show for now.